Hello everyone. So today I'm going to present my WIT project, that is Winter in Data Science project, and it was on data-driven astronomy. And each year it was organized or designed by Analytics Club, IIT Bombay. So I was a part of this, and I'm thankful to Analytics Club, IIT Bombay, for organizing this project. And hi everyone, my name is Akash Arya, and I'm a postgraduate student here at IIT Bombay, MEMS department. So let's discuss about what I did in this project. Okay, so project duration was about 1 month, and there were some tutorials, uh, around 15 tutorials, and also some assignments to solve. And an analytics club also suggested the to take one course on Coursera, that is data driven astronomy, University of Sydney, right? So So in the tutorials, we have discussed so many things. So in the first tutorials, we begin with the basics of Python, list, strings, tuples, dictionary, and etc. and play around the code. And after that, we have discussed some libraries, that is NumPy, numerical Python. And after that, we have defined how to define some functions in the Python, that we have discussed. And in the matplotlib, first introduction to pyplot, how we can plot the graph and images in the that we have also learned. And after that, we have also learned about the astropy introduction, how we can also uh, scrap the web pages, and some basic about the HTML, right? And then how we can know more about the curve fitting, or we're using the fits image. And we have also learned more about the image reductions, some astronomical data, and how we can plot these in different type of styles uh, to our data, like subplots, how we can label them and access them using object-oriented approach, and how we can sensationalizing the plots using these type of matplotlib libraries, and how we can know more about the mathematical equations and their predictions using entropy quantities. So okay, let's discuss the assignment, what we have covered in the assignments. In the assignment, first we'll have to write the programs to find the number of moons for each planet. Data was given, and we'll have to order all these moons according to their size with the planets, right? And in the assignment two, we have to find the distance to the Behe cluster. So basically, Behe cluster contains a large amount of stars. So we have to calculate the distance for each star, and also their mean and weighted average for all the distances we have found, right, for the each star. Right? And for the assignment three, uh, we have to solve the using Hubble-Laminar law, finding distance of the galaxy, and how we can compute the physical separation between two galaxies, right? So that we have solved in the assignment 3. In the assignment 4, from gravitational wave data was given, we have to uh, uh, plot the data between stand and time versus frequency and time. So that we have solved here, like stand versus time and frequency versus time. And then we also plotted this data as a scatter plot, right? In the assignment 5, to found a reasonable estimate for the background count image, that we have done in the assignment 5, and plotting also the histogram. In assignment 6, we have to pass the web pages for the astronomical data and plot them using matplotlib. So okay, let's that we have discussed in assignment 4, how we have plotted the gravitational wave data. And in the assignment 5, that is CCD cameras in astronomy, how we can find the background count in the given image, right? So using the histogram plot, right, that we have plotted. And in the next assignment 7 problem, from the general relativity relation, the frequency and time relation was given, and we have to mm, take the points as a frequency and how we can plot the with the frequency and time plots, right? And in the assignment 7, we have to uh, uh, find the plot for counting the number of photons for the each pixel, right? So we found it as a Gaussian fit, right? And that was our data, how number of photons was spread, right? So in the assignment 7 was on the image reduction. So how we can reduce the images and using these techniques, Python program, we plotted all these graphs and reduced our images and plotted the histogram of the background, right? So we can see very clear images after image reduction, right? So in the assignment 9 problem, we have to plot the HR diagram that is given for the cluster in different curve bands and in the problem first that we have plotted. So for the problem 9, we have to put them into by two subplot grid and with both x and y axis, because in the problem first we have not given x and y axis for all. Here we have given the x and y axis and label them accordingly with the data. Okay, so it can be very easy to compare all these uh, four. So in the assignment 9 problem 3, so that we have plotted earlier, in this graph we have to discuss the following regions like main sequence, subgiant, branch, red giant, and all these uh, regions that we have seen so far in the mm, right diagrams. Okay, all these regions are plotted. So in the assignment 10, arc test was given and data was given for that, and it was a prominent star. It is prominent star for the Boost constellation. So we have to estimate the temperature of the Arcturus within plus minus 50 Kelvin. So it behaves after finding or plotting the graph. We see that it behaves like a perfect black body, right? So after doing all these assignments, because we have to solve the 10 assignments out of 15 that we have done, and after that we have started the Coursera course suggested by Analytics Club, and uh, that is uploaded on Coursera by University of Sydney on data-driven astronomy. And instructor were Dr. Tara Murphy, associate professor, and Dr. Simon Murphy, postdoc researcher. So what was the course outline? So we in the week first they're thinking about the data and how we can think about like computational and discovering pulsars in radio images and how we can speed up. In the week two we have discussed more about the how we can increase our speed, uh, uh, like because big data makes things slow, and how we can, so it can also reduce our time and complexity also. And we have also explored about the black holes at the center around the massive galaxies. In the week 3 we have mm, did something related to SQL, how we can use our database and analyzing our data, and how investigating exoplanet and other solar systems. And in the week 4, they have discussed about managing your data, how we can set up our database, and exploring the life cycle of stars in our galaxy. And week 5, learning from data, how we can using the machine learning models, how we can investigate use our data and calculate the redshift of distant galaxies. And for the classification, using machine learning tool, classify your data and differentiate it according to the different models and how we can investigate different type of galaxies. This was the course outline that we have seen in the course, right? So this was the whole thing that we have done in this project. And thank you so much. Thank you very much for listening or watching this video. And I have earned this University of Sydney Coursera certificate also. there. Thank you so much, Coursera and University of Sydney, for making this course, and wish you all the best. Thank you very much, everyone.